Well, hey guys, it's been about a month, so I figured I better get a video up. And I apologize for my nasally sound. I'm getting over a cold. But anyway, about 3 years ago, I put up a video about this circuit, and I think it's very useful and interesting. So I figured I'd make a new video of it. Well, what it is a LED electric field detector. Very simple circuit. Just has two LEDs connected anti-parallel in series with a 100K resistor, 100,000 ohm resistor. So what it does is, if you have a positive voltage here, it'll pass through this LED on the left, come down to the resistor to the negative side. And if this bottom side's more positive, it'll go through this LED. Well, the neat thing with this circuit is you can check polarity with it, because if this side is positive, and by the way, I'm using conventional current flow because it matches the arrow direction on schematic components as opposed to electron flow. But anyway, for polarity, if the top probe is positive, the left LED will light. Even if I turn this upside down, top probe positive, left LED lights. So, same thing here. So if this wire, this yellow wire, is positive, the left LED lights. And if I flip it over, black wire positive going in the top now, left LED light. So you can use it to detect polarity of a battery or whatever you're testing. The resistor is important because you want to limit current through this thing. Also, if you're probing around and you have some static on your body, these LEDs can be damaged by static, and that'll reduce the intensity of that, protect the LEDs. Now, before you build this circuit, you have to pre-qualify the LEDs. So you set up this little test circuit here, putting the LED in series with a 1 mega ohm resistor. Put 3 volts across it, and the LED should light up very dimly. The reason you do this is because a lot of different types of LEDs don't give off light at very low currents. If there is a defect in the crystal structure in the die of the LED, it might pass what's called dark current. Dark current just means current passes through the LED and it doesn't attribute to making any light. Here's the qualifying circuit here. All it is these two batteries. Use fresh batteries. I hooked it up to the 1 meg resistor, and look at that. The LED is actually glowing at very low current. This is actually 800 nanoamps going through that LED, or 0.8 microamps. And I can get it down to probably about 200 nanoamps and just barely be visible. So that tells me this LED is good to use in the circuit. So I can test another one and I'll have the second LED and we'll be good to go. Now you might be saying, well, don't these LEDs have to have 3.2 volts on them? Well, that's true for normal currents, but this LED is actually starting to glow at 2 volts. Yes, its normal operating voltage at 20 milliamps would probably be around 3.2 volts or so. Well, I'm going to take this little detector and see what we can get into with it. Okay, I'm in the kitchen now, and I have one lead hooked up to the metal faucet and just holding on to the other end. It's kind of dark because I have the lights off, but see that when I touch the one end of it, see how the LEDs come on just very weakly, but they do come on. And I'm just standing in the middle of the kitchen here. I'm not touching anything. And when I shuffle my feet around like this, the LEDs flash. If I shuffle them, kind of have to slide them. I guess it's the static. Pretty neat. Now I hooked it up to a metal bracket on my refrigerator, and with that, when I touch the other end, it glows pretty brightly. And I'll touch the stove. I think it's really bright. Funny thing is, I can touch with my bare hands both brackets at the same time. I don't feel the slightest tingle. Well, my house is built in 1942 before they used safety grounds, and I know the refrigerator circuit is not grounded. It's kind of, in this house, it's kind of mixed. Some circuits are grounded that they upgraded, and some aren't. And the refrigerator is plugged into one that's not. So you get some capacitive coupling from the wiring and the motor coils and things, and you get that leakage to the case, but it's very slight and you can't even feel it when you touch it with your hands. Well, only one LED sliding because I have it hooked up to a battery, and if it follows my logic, the yellow wire should connect to the positive terminal. Let's see. Yep, it was on the positive before it popped off, but the black is on the negative. So that's it, the electric field detector. One other circuit I want to try on a nice day, not a stormy day because of the potential danger of lightning. I want to hook it up to an insulated metal rod that is high in the air, and then connect the other end to ground and see if there is a slight flow of electricity, and we'll see if this thing gives off any light. We can detect the polarity of that as well. Well, that's it. Thanks for watching.